Welcome back, dear students. We are doing AOD, and from AOD we are doing tangents and normal. Okay, so we will continue our second video on tangents and normal today. Okay, so the first question for the day says find the equation of the tangent to the curve, this one. So this is the given curve out here. Okay, so the given curve is okay, so the given curve is root over x plus root over y is equals to a. Okay, that is, so can I write this as x to the power half plus y to the power half is equals to a? Yes, obviously, because you know that square root means to the power half, isn't it? Right. So let me call this to be equation number 1. Okay, now you need to see this is the given curve, remember. Okay, now whenever you find tangent, equation of tangent, first and foremost you need to find the slope of the tangent, which is given by dy by dx, isn't it? So we will differentiate this. Okay, so differentiating 1 with respect to x, right? So the derivative of x to the power n, okay, that is x to the power half, becomes n x to the power n minus 1 plus, we have plus, now derivative of y to the power n becomes half y to the power n minus 1 into, now as per chain rule you need to differentiate y. So derivative of y with respect to x is dy by dx, isn't it? And all of you know a is a constant, so it's gonna be equals to 0. Okay, right. So what you can do here is, see here carefully, I'll take out half common. Alright, so take half common, then what you can do is, this is x to the power minus half. Okay, x to the power minus half can be written as 1 by root over x, isn't it? Yes, plus half is gone outside, so similarly y to the power half can be written as 1 by root over y dy by dx, and this is equal to 0, right? So take this 2 out here, so what you are going to get is, you'll get 1 by root x plus 1 by root y dy by dx is equal to 0. And from here, if I ask you what is dy by dx, what is dy by dx, then you will say, first you take this out here, so you get minus 1 by root x, and when you take this root over y over there, so altogether you are going to get your dy by dx to be square root of y by x. Okay, so dy by dx will be negative of square root of y by x. Now remember, we find slope at some specified point, isn't it? And here the specified point is this one. Okay, so we will find dy by dx at this one. Okay, so therefore, okay, so I don't have space out here, let me do it this way. Okay, so we have dy by dx at the point. Okay, so at the point, okay, so given point is a square by 4 comma a square by 4. Now this is equals to negative of, now see here carefully, we have in the numerator y, and what is the value of y? Value of y is a square by 4. Now we have y by means divided by, so write this divided by as into. Now in the denominator you have x, isn't it? And x is a square by 4. Now since you have written this to be into, this a square by 4 has to be written as 4 by a square. Okay, now what you observe here is, you observe that this one and this one gets cancelled, and similarly 4 and 4 also gets cancelled, so this is square root of 1. Okay, and all of you know that square root of 1 is how much? It is exactly 1. Okay, so that's why. And also one more thing that you need to notice out here is, it is negative sign here. Okay, so it turns out to be square root of it is negative of 1. So this is your dy by dx. Alright, so therefore we need to find equation of tangent, isn't it? So therefore equation of the tangent is y minus y1. y1 is this one, remember. Okay, so a square by 4 is equals to dy by dx. Remember, for tangent you need to write dy by dx out here, which is how much? Which is minus 1 into x minus x1. x1 is also a squared by 4, isn't it? Okay, now open the bracket. So you get y minus a squared by 4 is equal to minus x. Okay, so minus into minus becomes plus a squared by 4. Okay, now bring this out here. So you get x plus y. Now bring this out there. Okay, so you get a squared by 4 plus a squared by 4. Now when you add them up, what you're going to get is, you'll get x plus y is equals to a squared by 2. So this is the equation of tangent for this point. Okay, for this curve at this point. Simple. You may pause the video and note down your solution. Let's look at next question. So next question says, let me read the question for you. Find the equation of the tangent to the curve. So this is the curve. Now see, one more thing that I want to say here is, this type of equation is called implicit functions, isn't it? Which we have done in differentiation. Now this kind of equation is called parametric equation, because x and y, both of them are given in two different equations. They are given separately. Okay, so this is my parametric equation out here. So the given parametric equation, okay, parametric equation is, so we have x equals to a sine cube t, so you can call this as 1, and another is y equals to b cos cube t, and call this as equation number 2. Okay, now all of you must be remembering how to find dy by dx for parametric equation. So first we find dx by dt, because you see parameter is t out here. Okay, so differentiating 1 and 2 with respect to t. So let's differentiate both of them. Okay, so first differentiate x with respect to t, you get dx by dt. Okay, so it is going to be a is a constant. Now it is sine cube t. First, for power you get 3 sine squared t into, now for sine you are going to get cos t. Okay, so this is your dx by dt. Now let's find what is dy by dt at the same time. Okay, now again in the same way we have b. Now for power it's going to be 3 cos squared t into, now for cos t your derivative becomes minus sin t. Okay, now remember you need to find dy by dx, isn't it? So therefore your dy by dx, so dy by dx will be equals to, all of you know the formula is dy by dt divided by dx by dt. So this is the formula for finding derivative of parametric equation. Okay, so what is dy by dt? It is, okay, so you can, if you want to rearrange this, that will be better. Can I write this as minus 3b sin t cos square t? Obviously I can do that. Divided by, we have dx by dt. Now dx by dt, in the same manner I can write this as 3a sin square t cos t. So this is your derivative. Now you see there are some things getting cancelled. For example, sin t and one of the sin gets cancelled. Similarly, cos t and one of the cos gets cancelled. 3 and 3 also gets cancelled. Right? Okay, very good. So we have next, we can find the derivative at, see, we want to find dy by dx at the specified point, and here the specified point is this one. Okay, so therefore dy by, okay, so just wait a minute. So we have dy by dx at t equals to pi by 2. That's what you are asked to evaluate. Okay, so it is, see here carefully. So we have, first and foremost, we have minus b by a, minus b by a. So see here we have in the numerator cos t, and in the denominator we have sin t. Okay, so we have cos t is cos pi by 2 okay, because we need to put the value of t to be pi by 2 divided by, we have sine t, so we have sine t is pi by 2. Now all of you know cos pi by 2 is how much? What is the value of cos 90 degree? Cos 90 degree is 0, and cos sine 90 degree is 1, so 0 by 1 is always 0. So that's why the entire thing, this, the value of your dy by dx, that is slope, turns out to be 0 here. Okay, right. So therefore equation of tangent, remember you are asked to find the equation of tangent. Equation of the tangent is y minus y1. Now where is y1? You must be wondering, where is y1? This value itself gives you y1. Okay, that is, this value gives you y1. So y minus y1 is b cos cube t is equals to slope. Slope is how much? Slope is 0 here, isn't it? So slope is 0. So let me write 0 out here into x minus x1, and the specified point out here is a sine cube t. Okay, and all of you know 0 into anything becomes 0, so you can write 0 out here. So this becomes y equals to, so if you want to take this out there, you get b cos cube t. So this is the equation of tangent to this given parametric curve. Alright, so you may pause the video and note down your solution. Let's look at the next question. So next question here on the screen says, find the equation of the tangent to the curve, this one, which is parallel to the line 2x minus y plus 9 equals to 0. First, let's look at this. Okay, so what is happening here is, see, it's simple. So you need to find the equation to the curve. So let's say this is your curve. Okay, so this is the given curve. Okay, you need to find equation of the tangent. Okay, so let's say this is my tangent. This is my rough diagram. Okay, let's say this is my tangent. Now, as per the question, this tangent, this tangent is parallel to this line. So parallel to this line means, let's say that this is the line. Okay, so 2x minus y plus 9 equals to 0 represents this line, let's say. So this line and this line, they are parallel. Now you know that the two lines will be parallel only if their slopes are same. That means, how to find the slope of the tangent? We'll find the slope of this line, and whatever is the slope of this line, that will be the slope of the tangent out here. I hope the concept is clear out here. Okay, so let's see. So number one, the given curve is the given tangent is, right? So the given tangent, no, not given tangent, the given line. Okay, the given line is 2x minus y plus 9 equals to 0. Okay, now if you remember from the prerequisites, see, for a general equation of a line ax plus by plus c equals to 0, slope is given by minus a by b. Okay, so what am I going to do is, I am going to find slope out here, and remember here this 2 represents your a. Okay, this is your a. Here you have minus 1. Okay, so remember it is minus 1. So this represents your b, and this 9 represents your c. Okay, so its slope, let's find the slope of the line. Okay, the given line is this one, which is parallel, right? Which is parallel to the required tangent. Okay, so therefore slope of the line, all of you know slope of the line, given line obviously. So slope of the line is going to be equals to minus a by b. Now what is the value of a? A is 2 by b. B is minus 1. So this turns out to be exactly 2. Okay, so therefore, see, if the slope of the line is this much, okay, now what we need to do here is, we need to find the point through which the tangent is passing, isn't it? See, we know the slope of the tangent now. Okay, so therefore slope of the tangent. Okay, so let me call the slope to be m. So slope of the tangent will also be equals to 2. because line is, this line and this tangents are parallel. Okay, you can mention that since the line and tangent are parallel. That will be better, when you mention this, that will be better for you. Okay, right. Now my question or my doubt is how to find the point through which the line is passing, isn't it? How to find, see, let me draw a rough diagram again. So if this is your curve and if this is your tangent at this point, my slope is 2, all of you know that. But my question is, what is this point? Okay, what is this x1 and y1? So how to find this? For finding this, what am I going to do is, I'll find out the derivative. Now why derivative? Obviously we are doing chapter on derivatives, isn't it? So that's why we need to find the derivative for the given curve, because for the given curve the value of dy by dx gives you the slope, which we already know. Now why am I finding slope? Remember, I want to find this point which is not mentioned out here. Okay, so let me erase this. So the given curve is, let me mention that the given curve is, okay, so the given curve out here is y equals to x square minus 2x plus 7. Okay, so differentiating both side with respect to x. So let's see what do we get. So you get dy by dx is equal to, so this becomes 2x minus 2 plus 0, isn't it? So plus 0 is not necessary out here. Now this is your dy by dx, okay, which gives you slope, isn't it? Okay, so in fact I need to mention what at which point, isn't it? So what will I do is, I'll do okay, so just wait a minute. Okay, so this is your dy by dx. So from here I'll calculate dy by dx at the point x1 y1. Okay, so it's gonna be equals to 2x1 minus 2. Okay, so therefore slope of the tangent, okay, so therefore slope of the tangent, okay, slope of the tangent, which is equal to how much actually, which is equals to 2. Now in place of slope of the tangent, can I write 2x1 minus 2? Can I do that? Obviously, because you know that dy by dx that at x1 y1 also gives you slope of the tangent. So that's why in place of this I have written this much. So this is equals to 2. So from here bring this 2 out there, so you get 2x1 is equals to 4. Okay, so you have, okay, so from here x1 is equals to how much? 2. Okay, now we got our first point x1. Now remember, we need to find y1 also, right? So for finding y1, what we need to do is, okay, so let me call this as equation 1. Okay, so I'll find y1 from this equation only, because remember, see, if this is the curve, x1 y1 is lying out here, isn't it? If this is the curve, then x1 lies out here. I got the value of x1. Now y1 also has to be lying in the same curve, that is equation number 1 out here. Is that clear? What am I saying? Okay, so that's why. Okay, so let me erase this part which is not needed. So what you can do is, you can go back a bit and copy whatever I had written out here. Okay, so from equation 1, okay, so from equation 1, so we have y1 is equals to x square, x1 square, right? So x1 is how much? 2. So it becomes 2 square minus 2 into x. X is how much? X is 2 plus 7. Okay, see here carefully, x square minus 2x plus 7. So let's evaluate this. This is 2 square is 4. So 4 minus 2 into 2 is 4, plus we have 7. These two gets cancelled. So again we got 7. So therefore the specified point, okay, specified point means the point at which we need to find the tangent, okay, is x1 is 2 and y1 is 7. right? Okay then, so we have, so therefore equation of the tangent is, therefore equation of the tangent is, alright, so we have y minus y1 is 7 is equals to slope of the tangent, which is 2, isn't it? Slope of the tangent into x minus x1 is how much? X1 is 2. Okay, so it will be better if you want, see, it will be better if you can simplify this. Okay, I am not going to simplify this, so you may pause the video and note down your solution and kindly simplify and write down your equation of the tangent. So this is my first part. Okay, we will do the second part as soon as you copy this. So you may pause the video and note down your solution. Now let's look at the second part of the question. So this time, okay, so remember your slope. Okay, so from the earlier question, you remember when you differentiated this, you got dy by dx. In this question also, you need to find x1, y1. Okay, so you know that dy by dx at x1, y1 was equals to 2x1 minus 2. So the very same thing will be again useful in this case. Okay, now in this case, tangent is going to be perpendicular to this given line. Okay, so the given line is, first and foremost, you know that a line and two lines will be perpendicular to each other if the product of their slopes is -1. So what will I do is, first I'll find out the slope of this given line. Okay, the given line is, okay, so let me write down in normal form, so general form. So we have minus 15x plus 5y minus 13 equals to 0. Okay, so this is the equation of the line of this given line in general form. So therefore its slope, okay, all of you know the formula is minus a by b, isn't it? Minus a by b. Now what is a? A is minus 15 out here. A is minus 15 by b. B is 5. Okay, so 5 and this gets cancelled. Okay, so how much is this? This turns out to be 3. Okay, so therefore slope of the tangent. So again, let me call the slope to be m. Okay, so m is going to be 1 by, see, negative. Okay, so if this is the slope, when this goes into the denominator, you get m1 equals to negative of 1 by m2, where m2 is the slope of the given line. Okay, so that's why equation of slope of the tangent, that is m, will be equals to negative of 1 by, what is the slope? Slope is 3. So this is the slope of the tangent here, right? Okay, let me erase this part. Okay, now this also gives slope of the tangent, isn't it? Because this is the tangent which we got by finding the derivative of the given curve, isn't it? So therefore, by the condition out here, what we can say is, we can say that 2x1 minus 2 is equals to how much? This one, because this is also the slope and this one is also the slope, isn't it? Right. So from here, what am I going to do is, I'll find out the value of x1. So we have 2x1 is equals to, bring this 2 out there, so you get 2 minus 1 by 3. So how much is this? So 2 3s are 6, minus 1 is 5 by 3. So your x1 turns out to be, so bring this 2 down, so you get 5 by 6. So you get the value of x1 is 5 by 6. Similarly, we'll find the value of y1 using the same equation, that's the equation number 1. Okay, so from 1, okay, so we have y equals to, y is actually y1 is equals to x square. X square is, all of you know, it is 5 by 6 square minus, we have 2x, x is 5 by 6 plus you have 7. Okay, now I'm going to give you the final answer of this when you simplify this. Okay, so when you simplify this, so you get 5 square 25, 6 square 36, minus you have, so 2 and 6 gets cancelled, so you get 5 by 3, plus you have 7. So when you simplify this, okay, altogether you are going to get 217 by 36. Okay, so this is going to be the value of y1. All right, so therefore the specified point is, the specified point is x1 y1. X1 is 5 by 6 in this case, and y1 is 217 by 36. Therefore equation of the tangent is, okay, so let's find out what is the equation of the tangent. So it is y minus y1, 217 by 36, is equals to slope of the tangent, which is in this case minus 1 by 3, okay, into x minus x1. X1 is 5 by 6. Okay, right. Okay, now what we can do, we can simplify out here. Okay, right. So when you simplify this, this becomes 36y minus 217 whole divided by 36 is equals to minus, okay, so when you simplify this, so you get 6x minus 5 by 18. Okay, so what you can do here, you can do the cancellation. For example, okay, so 18 ones are 18, 18 twos are 36. So bring this 2 out here. See, I'm not going to do the entire simplification. Okay, so you get 36y minus 217 is equals to, so when this 2 goes out here, you get minus 12x. Minus into minus is plus, 5 into 2 is 10. Okay, now you take this out here. Okay, so when you take this out here, you get 12x plus 36y. Now bring this out there, you are going to get 227. Okay, so this will be the equation of the tangent to this curve. Okay, and this tangent is going to be perpendicular to this given line also. Okay, so you may pause the video and note down your solution. Let's take the last question for the day. So again, question is going to be simple, but this time you have to find equations. See here, this is in plural form, so that means you are going to get more than one normal. Okay, so you need to find equation of normal to this curve which are parallel to this line. Okay, so again we'll do the same thing. Okay, the given curve is 3x square minus y square is equal to 8. Okay, call this as equation number 1. So differentiating 1 with respect to x. Okay, now we have, so you get, this becomes 6x minus this becomes 2y dy by dx is equal to 0. Okay, now bring this x out there, so you get, okay, so when you bring it out there, so what you're going to get, 2y dy by dx is equals to 6x. So bring this 2y to the denominator, you get dy by dx is equals to 6x by 2y. Okay, so this is 3x by y. So this is 3x by y. Alright, so now we got dy by dx. Okay, now remember, we want to find dy by dx at the specified point, which is not mentioned out here. Okay, so what am I going to do is, I'll find out dy by dx at x1 y1. Okay, so this is going to be, so in place of x I'll write x1, so you get 3x1 by, you have y is y1 here. So this gives you slope of the tangent. Remember, slope of the tangent. Okay, Now what will be the slope of the normal? Let's find that. Okay, so slope of the norm, therefore slope of the normal is going to be slope of the normal. All of you know slope of the normal is calculated using minus 1 by dy by dx, which is 3x1 by y1, isn't it? So, which is equals to minus y1 by 3x1. So this is the slope of the normal, remember. Okay, now as per the question, normal is parallel to this one. Okay, the given line is, so we have x plus 3y minus 4 equals to 0. Okay, so this is the given line. So therefore its slope will be equals to, all of you know, it will be minus a by b. A is 1 and b is 3. So this is the slope. Therefore slope of the normal is going to be same as that of this line, because you know normal and this line, they are parallel, isn't it? So therefore slope of the normal is also going to be minus 1 by 3. But all of you know slope of the normal is minus y1 by 3x1, isn't it? Okay, so from here what am I going to do? We have minus 1 by 3. So from here you see 3 and 3 also gets cancelled. So from here you see that x1 is equals to y1. Okay, remember we haven't got the actual point as of now. Okay, so from equation 1, so what we can write is, we can write 3x1 square minus y1 square is equal to 8, because you know x1 and y1 both lies exactly on this curve. So that's why in place of x I can write x1, and in place of y I can write y1. Okay, now let's put the value. So we have 3x1 square. Now we have y1. Can I write in place of y1 x1? Yes, so in place of y1 I'm going to write x1 square is equals to 8. So this turns out to be, so we have 2x1 square is equals to 8. So from here, okay, so let me do it here. So from here x1 square turns out to be 4. Therefore what will be the value of x1? The value of x1 will be plus minus 2. Okay, so you have to be very careful with this. So I don't have space here. You may pause the video and note down your solution till here. Okay, so all of you know this is your equation number 1, and you got the value of x to be plus minus 2. Okay, now when x1 is equals to 2, I'm taking positive. Okay, then from 1 we have 3. Okay, so in place of x I'll write 2. So you get 2 square minus y1. So y1 can be written as okay, so let me write y1 only. So y1 square is equal to 8, right? Okay, so this is your this is what you are going to get from equation number 1. Okay, so we have, okay, so we have, this is 3 into 4 is 2 square is 4, so this is 12 minus, so the y1 square is equals to 8, and from here we have minus y1 square is equals to minus 4, isn't it? Yes, no, don't do this. Instead of doing this, what we can do is, remember what you got was, you know that when we have when x1 is equals to 2, now you have got two things, all of you know. Okay, when x1 is equals to 2, and another was when x1 is equals to minus 2. Two values for x1. Okay, we have, now all of you know x1 and y1 both are equal, isn't it? X1 and y1 both are equal. Now you know if x1 is 2, then the value of y1 is also going to be 2, and similarly when x1 is minus 2, then we have y1 will also be equals to minus 2 because the value of x1 is minus 2. Okay, so therefore the specified point is x1 y1, that is 2 comma 2. And in this case, see, these two are two different things. Okay, first you do this and after that you can do this. Therefore the specified point is okay, x1 y1, that's minus 2 comma minus 2 out here. Therefore equation of the normal is, okay, so all of you know y minus y1 is equals to, so what is the slope of the normal? Yes, slope of the normal was minus 1 by 3, isn't it, into x minus x1 is, okay, so instead of writing y1, directly write down the value, so it is 2. So x minus x1 is this much. Okay, and now the work is simple. So bring this 3 out here, so you get 3y minus 6, and you open the bracket, you get minus x plus 2. Okay, so bring this x out here, so you get x plus 3y. Bring this 6 out here, you get 8. So this is the one of the equation of normal. Okay, and here therefore equation of the normal is normal is y minus y1 minus y1 is minus 2 is equals to slope, which is minus 1 by 3, x minus x1 is also minus 2. Okay, now again we'll do the same. So bring this 3 out here, so you get 3y minus into minus is plus 3 into 2 is 6 is equals to minus x plus, okay, no, not plus, minus into minus is plus, plus into minus is again minus, okay, minus 2, right? So bring this thing out here, so you get x plus 3y. Now if you want to bring this out there, that can be done, or if you want to take this out here and write plus 8, that is also fine. So plus 8 equals to 0. So this is your another equation of the normal, right? So we got, see, as I told you, you will get more than one normal, and we saw that there are exactly 2 normals here. Okay, so with this we close for the day. So you may pause the video and note down your solution. Thank you very much.